In this video I'm going to go over the homework review graphs 2. Question 1, and these are going to be straight line graphs. So our first question, I need to find the equation of this graph here. We know that the equation of a straight line is y equals mx plus c, so I need to find what c is. That's the y-intercept. So I can see from my equation here that the y-intercept is -3. Then I need to find my gradient, and the gradient is the change in y of the change in x. So I want to choose two values that are on the line, that cross on the grid exactly. So to go from here to there, or from here to there, I'm going to go down 1, 2, 3, 4, and across 1. Because I'm going down 4, it's going to be -4, and across 1, and that simplifies to -4. So my equation y equals mx plus c becomes -4x minus 3. Question number 2 is just helping us with the notation that we use for our piecewise functions. So it tells me to highlight all the values where x is greater than 3. So that means that x can be any of these values there. And if I was going to use, if it was a piecewise function, I could say that it does not include 3. Here, this one is highlight the values x can take, where it's between 1 and includes 1 and less than 5. So that means I'm going to have 1 in this and come all the way up to 5. And I'm not including 5, but if this once again was a piecewise function, then I would put an open circle on 5, because it could be 4.5. Depends on whether we're using whole numbers or not. Question number 3 is finding the equation of a parabola or a quadratic equation. And I've designed this worksheet so that one side is using the intercepts and the other side is using the vertex. So this one is using the intercepts, so I can see here that it crosses at 0 and 6. So the general form for it in x, for a parabola when you've got your intercepts is -0 and x minus 6. Remember, it's always the opposite sign in the brackets. So up here it's in the +6, so inside the brackets it's -6. Here it's 0. This can be simplified to just x and x minus 6, because x minus 0 is just x. Now, in order to find the k value, that's how skinny or fat the graph is, what you need to do is you need to substitute in a known point. Now, I've used these 2 points, which is part of the reason why I've put a cross there. So I'm going to use a different point. I can read off that point there very clearly. So I'm going to substitute in the point when x is equal to 1, y is equal to -1. And I'm going to solve this equation for k. So that means that instead of y, I'm going to have -1. Instead of x, I'm going to have 1. And everything else about the equation stays the same. Now 1 minus 6 is -5. This gives me -1 is equal to -5k. And finally, that gives me k is equal to -1 divided by -5, and a negative divided by a positive is a positive, so that's 1/5, or if you prefer, 0.2. So therefore my equation is 1/5 x minus 6. My second equation is going to have the equation in the coordinates of the vertex, so it's x minus cross all squared plus up. Here I can see that I've moved across 2, so this is going to be 2. It's always the opposite sign inside the brackets, so it's -2, and I've moved the graph up 1, so it's +1 at the end. Once again, in order to find out what k is, I need to substitute a known point. So I've used this point and only this point, so I just have to choose any other point, and I can choose any other point that I can read off clearly. So any of these points will do, but I'm going to use that one there. That means then when x is 0, y is equal to 5. And if in here I put 0 and here I put 5, I can solve that equation. So putting in y is 5 and x is 0, I can then simplify this. 0 minus 2 is -2. -2 squared is positive 4. So on this side, I'm left with 4k plus 1 is equal to 5. And then getting rid of this plus 1, change side, change sign, I'm left with 4 is equal to 4k. And I can clearly see that k must be equal to 4 over 4, which of course is 1. And I don't bother writing the 1 in the equation. So the equation over here is x minus 2 squared plus 1. Question number 4 is just getting you used to translating these graphs around. Sometimes in our exam we have to translate the graphs. So because this graph is shifted up by 3 units, all I have to do is write the exact same graph but have it shifted up 3 units. And I illustrate that with a plus 3 on the outside. For this graph, it's going to be translated down 1 and to the right 2. Down 1 and to the right 2 means that I'm going to have my vertex here. So I actually rewrite this graph exactly the same, but it's in vertex form. So I know that k was 1, so it's going to be x minus 4 in this case, because that's where the vertex is, and it's plus 0 on the end, which I'm not going to bother to write. Finally, question number 5. The type of graph that we've got here is an exponential graph. Now, in order to find the equation of the exponential graph, we draw a line where the new asymptote is, and this becomes our new x-axis. We then want to go on to this new x-axis, and we want to look where it's 1 above, where the graph is 1 above, and I'm going to draw on a line there, and that becomes my new y-axis. So I'm looking at how I've moved from here through to this point here. An equation of an exponential can be thought of as base x minus across, and that's all to the power, so it's in brackets, plus u. So moving from this point to this point, I've moved across 2. Inside the brackets, remember, it's going to be minus 2, because it's the opposite sign. And I've moved up 1. So I've moved up 1. And our next step is actually to find out what our base is. Now, to find our base, we need to go from the new origin, or where the new x and y axes cross, and you go 1 across, and you see how far above the line the first point is there. Because it is 2 above the line, our base here is going to be 2. So our equation is y is equal to 2 to the power of x minus 2 plus 1. The question here is, what features does this graph have? And it has an asymptote. And an asymptote is a line that the graph gets closer and closer to but never actually touches. Our asymptote in here is called a horizontal asymptote, and it is at y is equal to 1.